Hello, my dear students. Welcome you all to Sri Jayendra Rank Zone classes. I am your mentor and your friend for the subject chemistry, and I will be dealing with the organic chemistry. My dear students, as you all know that we have started isomerism. In this journey of isomerism, we have completed the structural isomerism. We also discussed some aspects or the classification of the isomers. Today I'm going to start with a very important isomerism, that is stereoisomerism, and that too in stereoisomerism I'm going to start with optical isomerism. So let us begin with optical isomerism. Optical isomerism. Optical isomerism is basically is a type of stereoisomerism. Okay, it is a type of stereoisomerism or configurational isomerism. Optical isomers are the stereoisomers that differ in their behavior in rotating the plane of polarized light, the plane of polarized light, either in magnitude or direction. Such types of isomers are known as what? Optical isomers. They are known as what? Optical isomers. Okay. The phenomenon of existence of optical isomers is known as what? Optical isomerism. Okay. The substances which do not have any interaction with the plane polarized light are called optically inactive substances. Substances which do not have any interaction with PPL, that is plane polarized light, are called optically inactive substances. Optically inactive substances. Now, what is plane polarized light? First thing, what is plane polarized light? Ordinary light, it consists of electromagnetic waves which oscillate in all directions perpendicular to the direction of propagation of light. Okay, so plain polarized light is a beam of light which has oscillations only in a single plane is called plain polarized light. Okay, plain polarized light is produced by passing a beam of it is produced by passing a beam of beam of ordinary monochromatic light monochromatic light through a polarizer through a polarizer such as Nicol prism or a polarized lens or a polarized lens. Okay, so it is produced by passing a beam of ordinary monochromatic light through a polarizer such as Nicol prism or a polarized lens. Understood? A Nicol prism is constructed of two prisms of calcite, also known as Allen's pure, which is a naturally occurring transparent crystalline form of calcium carbonate. It is a naturally occurring transparent crystalline form of calcium carbonate. Okay, so a Nicol prism is constructed of two prisms of calcite, okay, which are joined together with a thin film of Canada balsam. Okay, both the are joined by and having a liquid of refractive index 1.4865, which is equivalent to glass. Okay, now this is the Nicol prism. So plain polarized light, it is a light in which oscillations take place only in one of the possible planes. Okay, So when polarized light is passed through the liquid or dissolved state of such substances, when plane polarized light is passed through the liquid or dissolved state of such substances, dissolved state of such substances, the plane of oscillation gets rotated through some angle. The plane of oscillation gets rotated through some angle towards left or right, towards left or right. The substances which rotate the plane of polarized light are called optically active substances. Are called optically active substances. Understood? And which cannot rotate the plane of polarized light are called optically inactive substances. If the plane of polarized light rotates in the clockwise direction towards the right are called dextrorotatory. Known as dextrorotatory, denoted by small letter d or plus. If it rotates in the anti-clockwise direction, is towards left and are called levorotatory, denoted by small l or minus. Okay, understood? This is the ordinary light in which the photons, the light particles, they are in each direction. They are okay. When it is passed through polarizer, Now the light particles, they will move in one direction. Okay, this is the direction of propagation of light or plane polarized light. Now when it is passed through the sample, either it turns to right or it turns to left. The amount of the substance means the concentration, and the amount of the rotation caused by an optically active compound depends upon following factor. First is wavelength of light beam. Second, temperature. Third is density or concentration. And the fourth is length of the solution through which light beam has been passed. Understood? So these are the factors on which the amount of rotation of an optically active compound depends upon. Okay. Now, specific rotation. Okay. When we talk about the Nicol prism or the polarizer, it is having two prisms, the first and the second. Both are basically parallel Nicols. Okay. The second Nicol prism is turned 90° to the first, known as cross Nicol. Okay. No light is transmitted through the first, or we can say the first Nicol. The second Nicol transmit the light ultimately. Okay. The second Nicol prism is also known as analyzer, while the first is polarizer. Okay. Now, specific rotation. The specific rotation of an optically active compound, it can be written as the amount of optical rotation observed when the plane polarized light is passed through a solution of PPL is passed through a solution of 1 gram per ml. Concentration solution in a 1 decimeter long tube. decimeter long tube. Okay, it is denoted by alpha, specific rotation. Okay, this is specific rotation. Now the cause of optical activity. What are the causes of optical activity? In order to exhibit optical activity, an object or molecule must be chiral. The first cause is chirality or asymmetric carbon. Okay. Second, any molecular object is said to be chiral if does not have any plane of symmetry or elements of symmetry. There are different elements of symmetry, mainly plane of symmetry or a center of symmetry. Okay. Now, what is plane of symmetry? It is a plane which divides an object in such a way that the part of it on one side of the plane is the mirror image. Mirror image formation if the object is divided by an imaginary plane of symmetry. You will be getting a mirror image formation. Okay. Ball is symmetrical while hand is asymmetric. Ball is symmetrical while hand is asymmetric. Okay. A chiral molecule or the object is non-superimposable on its mirror image. Is not having any superimposable on its mirror image. Okay. Chiral object or molecules are also called disymmetric objects or the molecules. The word chiral, in fact, is derived from the Greek word chir. Chir means hard. Now, chiral center. A carbon atom bonded to four different atoms group in the molecule is called chiral center. Okay. Carbon having four different groups. Carbon atom bonded to four different groups in a molecule is called chiral center. Okay. The chiral center in the molecule is represented by asterisk sign. Okay. This is chiral center. Some more examples of molecules having one chiral center are this is also a chiral center. Now, compounds which are mirror images of each other are not superimposable and are termed as enantiomers. Compounds which are mirror images of each other and form non-superimposable images. The compounds which are mirror images of each other and are not superimposable. They are known as what? Enantiomers. And the phenomenon is known as what? Enantiomerism. So what are enantiomers? Enantiomers are the molecules which are mirror images of each other and they should be non-superimposable. Now keeping this mirror image, okay? So these are enantiomers. Characteristics of enantiomers. Some of the important characteristics of enantiomers are: first is they have identical physical properties such as identical physical properties such as Melting point, boiling point, density, refractive index. Enantiomers are optically active substances. They are optically active substances. They rotate the plane of polarized light in opposite direction but to the equal extent. They rotate the plane of polarized light opposite in opposite direction but to the equal extent. But to equal extent. Okay. Enantiomers have identical chemical properties as well. Identical chemical properties. They form same product as a result of chemical combination. However, their reactivity, that is rate of reaction with other optically substances, may be different. Enantiomers have different biological properties. Different biological properties. For example, sugar plays important role in animal metabolism. Another sugar does not play any role in the metabolism. So, when they differ in biological properties, the dextro sugar it plays an important role in animal metabolism, while the levo sugar does not play any role in metabolism. Now, coming to next representation of enantiomers that I will be completing in the next turn. Till then, bye bye. Take care. Stay safe. Stay healthy.